Okay, today we're doing distance, rate, and time equations. We're using the formula distance, rate, and time. So there's three different scenarios that could happen. And when we do our word problems, I want you to draw out what's happening. The first situation would be where two automobiles or two planes start at the same place. And they're basically both traveling to the same place. So it's basically like saying distance A plus distance B is equivalent. You should be writing all this. Okay? Scenario number 2 is where they start at different points and they're traveling towards each other. One's going faster, one's going slower. They might travel different distances, but the different distance of A plus the distance of E is equal to a total distance of C. Okay? And then you've got a scenario where they start in the same city. One is traveling, let's say, from Los Angeles to New York, and the other is traveling towards Hawaii. How long? Until they're like 3,000 miles apart. So the distance that one travels plus the distance of the other altogether also equals the distance of C. This 2 would be A plus B equals C. Now the bottom part you don't really need to write, but there's 2 ways to solve. You can do it with 1 variable or 2. You don't need to write these full sentences. Abbreviate. 1 variable or 2. Give me a thumbs up when you think you are done. All right, so let's try our first one. 2 planes take off from the same airport at the same time. One plane travels east and the other travels west at 200 miles faster than the eastbound plane. Find the speed of each plane if they're 2,000 miles apart after 2 hours. So, we're starting with the first thing we have to do is label on the left. We're talking about the east plane, and the west. And I'm noticing that they talk about speed, they're talking about distance, and they're talking about time. So I'm using that formula. Rate times time equals distance. Okay? Now, 2 planes take off from the same airport at the same time. Draw what's happening. Right? They're taking off. Are they going in the same direction or in different directions? Different directions. So of all those scenarios, what's it going to look like?
Travel away.
Right. Right? So we've got I'm going to go the direction. This is the east, this is the west, and then this is the total distance, right? Do we know what that C is?
No. Wait, yes, 2,000 miles.
2,000, yeah, they're telling us. Do I know the exact distance for the east plane?
No.
Do I know the exact distance for the west plane?
No.
So I can't put that 2,000 there. Okay. What do we know that I can fill in the box?
It's the west is going 200 miles per hour faster than
Okay, that's kind of tricky. There's something that's very easy to place. Yep.
the rate of the east plane.
Nope. No. Rate is implied. Yes.
Time.
The time is what?
2 hours.
We know now. Let's look at this. Can I get somebody to come here? We're gonna act this out. So you on the recording, I don't know how to do this, but other than you can listen to us. We're going to walk this out. Come here. You're going to be the fast plane. Okay? You're the faster one. Are you east or are you west? Who's west. Faster? West. West is going faster. So, okay, we're both like leaving at the same time. Ready, set, and go. And stop. That was 200 miles apart. So you see how I traveled So my time was the same, but my distance was what? Different. Because one plane is going faster. So we know that we can't write the same distance in there. And the time is the same. We both start at the same time, end at the same time. And the distance together we know is 2,000. All right, now the rate. Here's how we do it. We don't know the rate. We only know that they're 200 miles per hour different, right? So we're going to call them both R. But what do we know about the west one? Plus 200. Okay, now we don't know the distance of the first one, and we don't know the distance of the west, but we do know the distance of them together. Remember, what do we do going up and down? We add. So if I multiply across, I get 2R. And if I multiply across here, I get 2 times R plus 200. And so what happens to be my equation? Can anybody read it to me? Fionn?
2R plus 2 to the quantity of R plus 200.
2 times the quantity of R plus 200
Equals 2,000.
Equals 2,000. And it's 2R plus 400 equals 2,000. It's 4R plus 400 equals 2,000. Subtract 400. 4R equals 1,600. Divide by 4, divide by 4. R equals 400. So, that tells me what? Of what? The east plane. So it's 400 miles per hour. Right here. 4 divided by 1,600 is... Oh, right here, because I distributed 2 times R, and here is 2 times 200, okay? All right, so I got that is 400, and what would the west be? If this is R is 400, it will be 600. And so we're going to say the west is 600, and it's MPH, and the east is 400 MPH. How'd that feel? Now, normally I like to solve these with one variable. I think it's easier. I never know until I attack the whole problem and fill it out in the boxes. I never know what I have until I place what I have. I don't walk into this problem and go, oh, I know exactly what to do. I fill what I know in the boxes, and then I look for what's implied. Okay? Can I erase that? All right, let's go on to, we're going to do the same problem. They used X. If we're talking about a rate, I want you to use R. Okay? On the next one, you'll see, I don't really think that using 2 variables makes sense because they use X and Y. Oh, look what happened. Some of my very favorite students, well, all my students are my favorites, hijacked my computer, inserted their picture, and I have not taken it out after all these years. This one is at Berkeley. That's Isaac Engelberg. He's at Berkeley. And Katie's at Berkeley. And Harper is at UCSB, and Tulia is at San Diego State. That happened in an after-school session, probably 7 years ago. Yeah.
Once you find the rate for both east and west, are you done?
Yeah, because let's look at what it said. It said find the speed. A speed is a rate.
Okay.
Okay. Now we're going to do it with two variables. Do you have to do it with two variables? No. You get to choose your method. But I'm going to show you it can be done with two variables. So we're still talking about east and west. We're still doing rate times time equals distance. We know that the time is still 2. The 2,000 is still going in the same place. The distance is 2,000. This time I'm going to call one rate X and one rate Y. And we're going to use the equation right here, the language, to create an equation. West is 200 faster than east. Right? West is what? Y. West is the Y. Is equals 200 faster than X plus 200. And then we can multiply across 2X, 2Y. You guys with me? How I got that? I personally feel like it makes more sense to me the other way. 2X plus 2Y equals 2,000, and I can substitute in. And notice we get to the same point. I'm not going to tell you what you have to do, which way to solve it. I think you're going to fill in what you know, and you will naturally have a path. Does that make sense? You might see something with two variables. I personally see these easier. I mean, I could have done well, I don't want to bring up another way, a third way right now, because you're going to have enough on your plate. So fill in your boxes and see what kind of equations you build within the boxes. Does that make sense? All right, here's another one. Let's go to the next one, actually. Okay. Joe and Lisa are 44 miles apart and start biking toward each other. If Joe is traveling 6 miles per hour faster than Lisa and they meet in 2 hours, how fast was each traveling? So who am I comparing on the left?
Joe and Lisa.
What do I put on the top?
Rate times time is
Equals distance. So anytime you see speed, time, and distance, you're going to set it up something like this. Okay? Okay. So, okay, what can we fill in right away? Elise.
You can fill in that the time.
The time. They're 2 hours. They're both traveling. So I can draw the pictures. So Joe and Lisa are 44 miles apart. Here's Joe. Here's Lisa. Let's draw what's happening. And Joe's traveling faster, so I'm making him go longer. Right? Yep.
It says they're riding 44 miles apart, so wouldn't it be travel away?
It says they're biking toward each other.
Oh.
Okay? So I'm drawing what that says. So I get an idea, because I'm going to have distance 1 plus distance 2 equals the total distance, right? Okay, what can we fill in? We said that the time is 2 hours. We know that in this whole thing, each of them spends, this one spends 2 hours and this one spends 2 hours. Does that make sense? Okay. Then we have, how am I showing the rates? Somebody else. Beyond.
Joe is traveling, so R plus 6.
R plus 6. And
Lisa's just R.
just R. And then where does the 44 go? Is that Joe's distance? Is that Lisa's distance? Aton. It's the distance altogether. So I'm going to make another box and add that 44. So what do I do to the top? Rate times time. What do I do going across? 2 times R plus 6 and 2R. So what's the equation? Why don't you guys finish it up? Pause the recording, finish up the equation, and solve for R. Okay, Max, what are you getting?
My equation was 2 times the quantity of R plus 6 plus 2R equals 44. And I got that Lisa is traveling 8, her rate is 8 miles per hour.
Good.
Joe's is 14 miles per hour.
Good. So Lisa is 8 mph and Joe is how much? 14 miles per hour. You can check your work. Pause the recording. All right, how do you feel about these? This is a lot like the last one, right? Okay. Now you'll see they're just using X. Why don't I like X? Because you don't know if you get a time, a distance, or a rate. So try and use the variable that's unknown. Okay? All right. Now I have to go back. Okay, the next one is a little bit different. Karen leaves for work traveling at 50 miles per hour. 15 minutes later, Mark chases after her with her briefcase traveling at 70 miles per hour. After how many minutes does he catch her? From the time that she left, right? Okay. What do I put on the outside? Let's go with Noah. How am I setting it up on the outside?
Karen and Mark.
Okay. And on top?
You would put rate times time equals distance.
Perfect. All right. So what can we fill? What do we know for sure, Nicole?
You know that the total is 50 miles per hour.
The total what? The what? Miles per hour, is that a rate, a time, or a distance?
Distance.
It is not. Miles per hour is a speed. Nope, it's a speed. A speed is a rate. Okay? So you would kind of get that from driving. So like people that are driving go-karts and stuff a lot, they know that. But when you see MPH, rate is a combination of time and distance. Does that make sense? So, what is Karen's rate?
50 miles per hour.
She's 50, and what is he?
70.
That's right. Okay, now, time gets a little tricky here. Yes.
So it's Karen is T and Mark is T minus 15.
Very close. Karen is T, and,
Oh yeah, plus 15. Shoot.
okay, T, and what'd you say?
I said minus, but it's plus, right?
What did you say?
I said T minus 15.
T minus 15. He's traveling 15 minutes less.
Yeah.
That's correct. T minus 15 means they travel the same time, but he's doing 15 less. Right? Because he leaves later. She doesn't stop and then he travels for 15 more. He just drives faster and catches her. Does that make sense? They both leave at the same time. It's kind of like a race. Here's Karen and she's leaving. 15 minutes later, he starts and he catches her. She never stops. They're both kind of going at the same time. Yeah,
For Karen, could you also do T plus 15?
we could have done T plus 15 in comparison to T, or, yeah, you could do it either way. You could name Karen T plus 15 minutes, but wait a second. We're in hours. So we've got to do some conversions here. Yeah.
I was gonna say since it's not, so would be T minus 1/4.
Yes, 1/4 of an hour. 15 minutes is 1/4 of an hour. Okay, now what do we do going across? Multiply. So I get 50t, and over here I get 70 times t minus 1/4. Now, didn't we say this is kind of like a race? So what's implied? What is the same?
Oh, the finishing point.
Okay.
End up.
The rate, the time, what? The distance is the same. When it's a race, your distance is the same. So can't we just set these 50t equals 70 times t minus 1/4? 50t equals 70t minus 70/4, which is 70/4 is 17.5. Good. You guys do the calculator. Okay, now I'm going to subtract 70t, subtract 70t. Negative 20t equals negative 17 5/10. Divide by negative 20, divide by negative 20. Now this becomes very easy for me because I give quizzes all the time out of 20. 17 out of 20 is 85%, so that would be 0.85. This takes me up to 87.5%, so it's 0.875. Now that's awkward. 0.875 hours? 0.00 and 875 hundredths of an hour? Of an hour. Of what? An hour, if I want...
7/8, right?
You could do that. You could do, okay, 0 and 875. Okay, turn it into a fraction. Let's convert from hours to minutes. Isn't this in hours?
Yeah.
So I could do my dimensional analysis, hours in the bottom, minutes on top. 1 hour is to 60 minutes, so I'm multiplying it by what she said was 7/8 or 875 thousandths. Sorry. And so I'm doing the hours cross cancel. When you multiply, you get 52.5 miles. So make sense of the answer. Make sense of the answer. What's 52.5 of a mile? What's the question they're asking, guys? After how many minutes does he catch her? After 52.5 minutes.
Yeah, because you said
It's not miles, it's minutes. Minutes, sorry. Yeah, what did I do there? This I put hours to miles. Should be minutes, right? That's what I did. Okay. Do you understand that? It's hours to minutes. I shouldn't have put miles. Okay, are you guys good? Yes, understanding that one? You ready to add a little wind and current? Yes, Julia. Okay. So now we're going to go to wind and current problems. Current is the water, wind is the air. It's the same for airplanes and boats. I personally find these to be the easiest distance problems because usually a lot of times they're implying like the boat goes there and back. So that right there implies that my distance is the same. The difference is like you have two different speeds. The speed of the plane or the boat that the engine is moving, right? The engine turns on and it's moved. And then there's the speed of the wind. Now, or the current, the water. So let's take like the lazy river. You guys have been on a lazy river before, right? So if you go with the river, you don't even have to do anything and the current will move you. It has its own speed. Now, if you turn the motor on your legs while you're in the lazy river and you start walking, don't you like pass everybody by leaps and bounds? So that's what's happening. When you go with the current, there's the speed of the boat and the speed of the water that's pushing you. And what happens if I try and come back? Because my mom is old and she's left all the way behind. And it's taking you twice as long because you're going against the water. It's slowing you down. The same thing happens in the wind. And the wind has some special names. When you're in the airplane and the wind is behind you, what is it doing? It's what? It's pushing you and it's propelling you forward. So it adds speed. The wind, if you're going, and so we call that when it comes from behind and hits your back end, we call it a tailwind. If you have a tailwind, you're going faster. Versus if you turn around and you're going into the wind, what's happening? What's the wind doing?
It's pushing you back.
It's slowing you down. It's pushing you back. A headwind slows you down. Okay? Tailwind, headwind. Got it? All right. The only thing I'd like you to do is every time I use P, I want you to use, since it's a speed, say R. Okay? Okay, so we're going to say P is the speed of the plane, or R is the speed of the plane, and W is the wind speed. Okay? We're still doing distance, rate, and time. And we've got two situations. A light plane flies 12 miles with the wind, 1,200 miles with the wind. He's going like this, 1,200 miles. And then the return trip, now in this case they're telling us our distance, but sometimes that helps us. The return trip is also 1,200. Okay, we've got rate, time, and distance. You guys with me? And we've got with wind, and we've got against the wind. All right. What do we know? What can I place right away without thinking? Distance is 1,200. Not together, but each one is traveling 1,200. Okay? Okay, where do I put the 4? Time. That is 4. Good. And where do I put for with wind? And where the other one is against the wind. The more time, the 5 is the against. Now we're talking about our speed. Do we know the speed of the plane?
No.
So we call it R, both ways. The difference is with wind would be plus W and against wind would be minus W. So what are my two equations? Multiply across. What's one equation? Somebody? Noah.
4 times in parentheses R plus W, or the quantity of R plus W equals 1,200.
And the other one?
5 times the quantity of R minus W equals 1,200.
Good. Okay, I'm going to just go on to the next. Do you guys have this written down? Okay. So you remember we're still using R and R and R and R and R. Okay, let's get P plus W alone. What would I have to do? I don't want to distribute. I like that P plus W because I'm noticing, my R plus W and R minus W. What do I do to get rid of the 4?
Divide by 4.
Divide by 4. Both sides. Cancel. What am I doing on the other side?
Divide by 5.
Divide by 5, divide by 5. And I get R minus W equals, is it 270? It's 240, sorry. 240, and this one is R plus W equals 300. Well, now I'm set up very nicely. R minus W equals 240. Cancel. 2R equals 540. Divide by 2, divide by 2. R equals what?
270.
Okay, 270. So the question says, what is the speed of the plane and what is the speed of the wind? Okay, that's 270. The speed of the plane is 270 and it was miles per hour. I can use either of these, or even I can use these. Aren't these equivalent? Right here? Either of those equations. So I can just substitute in 270 minus W equals 240. Subtract 270, subtract 270. Negative W equals negative 30, so W equals 30. So the wind is 30 miles per hour, and the speed of the plane is 270. Yes, you're understanding, or no, you're not? How are you guys doing? Okay, we got one more. Let's see, much time do we have? We can do, okay. Can I erase?
Yeah.
Okay. Okay, here we go. Okay. Ooh. I must have written this one. Okay, here we go. A train leaves Sherman Oaks traveling 80 east at 80 kilometers per hour. This is not the one I was looking at. Okay. A train leaves Sherman Oaks traveling east at 80 kilometers per hour. An hour later, another train leaves Sherman Oaks on a parallel track at 120 kilometers per hour. How far from Sherman Oaks will the trains meet? Let's see. A train leaves Sherman Oaks traveling east. I think they're meaning west. Let's pause this. Okay, I think this is actually one of the homework problems. So a train travels east from Sherman Oaks. Here's SO. And I'm going to draw the picture. And that is, she's leaving, heading east, and they're going 80 kp hour. Okay, then on a parallel track, an hour later, another train leaves Sherman Oaks on a parallel track, and this one's going faster at 120 kilometers per hour, kph. Okay, so let's figure this one out. Let's make our box. Now, when I start doing this, I don't know what I'm going to do. I don't know necessarily exactly what the equations are going to look like. Okay, so I'm doing rate times time equals distance. And I'm gonna differentiate them by the fast train, the faster one and the slower one. I'll call one the fast. Let's call the first one the slow one because that's who left first. Slow, and let's call the other one the fast. Okay? What do we know right away that I can fill in? What do we know right away? Yeah.
Time is an hour.
No. An hour later, one leaves.
So would it?
It's not them catching each other. They want to know how far. An hour later, another train leaves Sherman Oaks on a parallel track. How far from Sherman Oaks will the trains meet? Okay. Okay, how about Jamie?
Could you put in the rates?
Yeah, we can for sure put in the rate. So that's 80, and the fast one's going 120. What do I know about the time? Elise?
That the faster train leaves an hour later than the slower train.
Okay, so how are you?
Would it be t plus 60 or t plus 1? I don't know.
Well, you know why? Because it's kilometers per hour. We're going to keep it in hours.
Oh, okay.
Okay, so you got to kind of match up with the speed. Okay? And plus, okay, so what are we calling the slow? No, the slow time.
T.
T, and the other one is T minus
T
1.
minus 1.
Good. Now, what am I doing?
Multiplying across.
Multiply across equals 80t equals 120 times t minus 1. Now what?
80t equals 120.
Yeah, because this is a situation where distance A equals distance B, right? They end up traveling the same distance. Now, we're solving for time, but I'm going to eventually use that because they want to know how far. Does that make sense? So you can see I've eliminated the other variables. So I get 80t equals 120 times t minus 1. So it's 120 t minus 120 equals 80t. Okay, minus 120t minus 120t. It's negative 40t equals negative 120. Divide by negative 40. Divide by negative 40. And t equals what?
3.
3. Okay? Now, are you guys with me? 3 what?
Hours.
3 hours. So it takes this person, the slow train, 3 hours, and this one 2 hours. But they're asking how far. That's a distance. Isn't distance equal to rate times time? So we know the rate is 80, and if the time is 3, what is the distance?
240.
240, and we are in what?
A mile.
Kilometers per hour.
But if it's distance, it's just going to be 240 kilometers. See how sneaky that was? We solved for t. Once I found t, I had the ability. So the one thing you always have to do is go back and ask yourself, what are they asking me? All right, I'm going to stop the recording there. I think the rest are just more homework problems that I've typed up. Yes?
So since it's a word problem, should our answer be a sentence? Like they will.
Not a sentence, but it should be 240 kilometers. Should be have units attached to the end.
Okay.
All right, and that's the recording.